Okay, so we're talking about radicals in this video. So if we're looking at something like the square root of 9, well, we know the answer is 3, but let's look behind what it means. So if we look at the square root of 9, that's the same thing as 3 times 3, or the square root of 3 squared. So the square root and the exponent squared on the base of 3, those are inverse operations, so they cancel each other out. So that's how we can say the square root of 3 squared is 3, which is the same thing as the square root of 9 is 3, or the square root of 3 times 3. We look at that square root of 3 times 3. That's a pair. We have a 3 times a 3. And when it's a square root, we need to look for pairs. So 3 times 3 is a pair of 3's, so we can pull that out as just a 3. So now let's look at another one. Okay, so we're going to look at the square root of 81. But we're going to look at it in a little bit of a different light. We can also say the square root of 81 is 9 times 9, or we have the square root of 9 squared. Again, all of those equal 9. 1, because we have a pair that we can pull out. 9 squared, we have the inverse operations happening, so those cancel each other out. Or we just know the square root of 81 is 9. But let's look at it a little bit differently. So the square root of 81 also equals the square root of 3 times 3 times 3 times 3. And 3 times 3 is a pair of 3's, so we can pull a 3 out and put it out in front of the radical sign. So that's 3. And then we're left with 3 square root 3 times 3 under the square root sign. And again, we have another pair, so we can pull that out of the radical, and we end up with 3 times 3, or we can also just obviously call that 9. So the point of this is looking at it in terms of pairs. Pulling out groups of 2 of the same number out of the radical to put on the outside of the radical. So what happens if we have the fourth root of 81? So we have the fourth root of 81. We know that is the same thing as fourth root of 3 times 3 times 3 times 3. But this time we're looking for groups of 4 3's. Okay, 3 times 3 times 3 times 3 is also the same thing as 3 to the 4th power. And 3 to the 4th power is 81. So we can write that as 4th radical of 3 raised to the 4th power, where the 4th root and the exponent 4 cancel each other out, and so we get an answer of just 3. So you have to take out groups of 4, take the radical of the groups of 4 of the same base to pull out one of the bases outside the radical. So let's look at this in terms of, I'm going to move down my board just a little bit. So what if we have the 5th root of x to the 6th? Now what does that look like? Okay, so we're looking for groups of 5. So I'm going to rewrite this radical as the 5th root of x times x times x times x times x. So we're looking for groups of 5. Well, we have it. We have 5 x's and 1 left over. So we can take 5 of these x's out of the radical sign with just an x. But what we have left inside the radical is 1x. We need groups of 5. So the simplification of the 5th root of x to the 6th power is x 5th root of x. Okay, so let's look at this in real numbers. So we're going to look at the 4th root of 162. Okay, so let's break this down into the factors. Well, it's an even number, so we know we can divide it by 2. So now we have 2 times 81. 2 times 81 is 162. So let's break that 81 down again. So now we have the, just forgot my index number, we have 4th root of 2 times 81. Well, we can break that 81 down. We can break it down into 2 times 9 times 9, But that doesn't give us a fourth root. So let's break it down again. So now we have fourth root of 2 times 3 times 3 times 3 times 3. So I took the factors of the nines. So let's look for a group of 4. Well, we have 4 3's here. So we can pull these 3's out because we have 4 of them. Because the fourth root of 81 is 3. So then we end up with 3 fourth root of 2. And that 2 stays underneath the radical because we can't take an easy fourth root of it. So the simplification would just be 3 times the fourth root of 2.